Welcome to MRL. In this learning session, we will learn the solutions of exercise 2.1 of linear polynomials chapter of Ganith Manjari 9th standard CBSE textbook. Now let us begin with the first example. Now the first example is to find the degree of the given polynomials. We are given a polynomial here, 2x square minus 5x plus 3. The highest power of the variable is 2, and therefore the degree of this polynomial is 2, or it is a second degree polynomial. Now the second example, y cube plus 2y minus 1, the highest power of the variable is 3, therefore it is a third degree polynomial, or it's a polynomial of degree 3. Now coming to the next example, we have minus 9, which is a constant here, and a constant can be written as minus 9 into x raised to 0. Therefore the highest power of the variable here, it is 0, and therefore it's a 0 degree polynomial, and in fact all the constants are 0 degree polynomials. Now coming to the next polynomial, that is 4z minus 3. The highest power of z is 1 here, and therefore the degree of this polynomial is 1, or it is a first degree polynomial. Okay, please remember that. Now please know the definition of degree of a polynomial. Now coming to the second example, to write the polynomials of degree 1, 2 and 3. So we have to write polynomials ourselves of degree 1, degree 2 and degree 3. Now first degree polynomial means a variable which has got a power as 1, and therefore have a polynomial 5x plus 7, which is a polynomial of first degree. Then the second degree polynomial means the variable should have power 2, the highest power must be 2, and therefore it is 3x square minus 2x plus 4 is an example of a polynomial of second degree. And the third degree polynomial is that polynomial in which the variable has got the highest power as 3, and therefore 4x cube minus 3x square plus 2x minus 5 is a polynomial of degree 3. Now the next question is to find the coefficient of x square and x cube in the given polynomial. The polynomial given is x raised to 4 minus 3x raised to 3 minus plus 6x square minus 2x plus 7. Coefficient of x square is 6, and coefficient of x square is 6, and the coefficient of x cube is minus 3. Here that is not the degree, but the coefficient is being asked, and therefore the coefficient of x square is 6 and the coefficient of x cube is minus 3. Now to find the coefficient of z in 4z cube plus 5z square minus 11, if you observe the polynomial, there is no z here. That means the polynomial is absent. The z that is linear, that is a polynomial with one power, the first power, that is the power 1, is not there. Therefore its coefficient is 0. The coefficient of z is 0 here. Now to find the constant term of the polynomial, that is 9x cube plus 5x square minus 8x minus 10, the constant is minus 10 here in this polynomial. Please remember that. Now coming to the exercise set 2.2 of the same polynomials chapter of Ganith Manjari 9th standard CBSE textbook. Now the first example here is to find the value of the polynomial 5x minus 3 for different values of the variables given here. Now when x is 0, then p of x is 5x minus 3, putting x as 0, because p of 0 we have to find, and therefore find to 0 is 0, 0 minus 3 is minus 3. Therefore the value of 5x minus 3 is equal to 3 when x is equal to 0. When x is equal to minus 1, putting the value of x as minus 1 here, 5 into minus 1 minus 3, minus 5 minus 3 minus 8. So the value of 5x minus 3 is minus 8 when x is equal to minus 1. When x is 2, then p of x is equal to 5x minus 3, p of 2 is equal to 5 into 2 minus 3, that is 10 minus 3, and that is equal to 7. So the value of 5x minus 3 equal to 7 when x is equal to 2. Now the second example is to find the value of quadratic polynomial 7s square minus 4s plus 6 when s value is given as 0, minus 3 and 4. So let us find with s is equal to 0 first. Wherever s is there, put 0. So 7 0 square minus 4 0 plus 6. So the answer is 6. The next one is for when s is minus 3. So p of minus 3 will be 7 of minus 3 square minus 4 of minus 3 plus 6. So minus 3 square becomes 9, and minus into minus becomes plus 12 here, plus 6. So 7 9 is 63, plus 12 plus 6, that is 81 is the answer for that. That's the value of the polynomial when s is equal to minus 3. When s is equal to 4, the value of the polynomial is, wherever s is there, put 4. So 7 into 4 square minus 4 into 4 plus 6, and 7 into 16, 4 into 4 square is 16, minus 4 into 4 is 16 plus 6, and therefore the answer is 112 minus 10, and 102 is the value of the polynomial. Now there is an example given here, which is a statement example. The statement example very clearly tells us that the present age of Salil is given. The present age of Salil, assuming it to be x, his mother's present age is 3x. That means the statement is the Salil's mother's age is 3 times Salil's age. So assuming Salil's present age to be x, mother's present age automatically it becomes 3x because it's 3 times Salil's age. Now after 5 years, Salil's age is definitely 5 more years. That means x plus 5. Mother's present age will be again increased by 5, that is 3x plus 5. Now what we are given is after 5 years, Salil's age plus mother's age, when we add, the sum is 70 years. Therefore, x plus 5 in the bracket plus 3 in the bracket 3x plus 5 is equal to 70. Opening and simplifying the equation, we get x is equal to 60 by 4, x is equal to 15. That means Salil's present age is 15 years and his mother's present age is 3 times Salil's age, and that is 45 years. So read the statement, assume the variable, and then solve the example to get the answer. That is how it is done. Now coming to the second example, that is the fourth example here, we are given the difference between two positive integers is 63. Difference between two positive integers is 63 and the ratio of the two integers is 2:5. Now we have to find the integers. Now we do not know both the integers. So let us assume one integer as x, other integer definitely will be x plus 63 because difference is 63. And the ratio of the two integers, that is x upon x plus 63, is equal to 2 by 5. Now simplifying this, cross multiplying, we get x into 5 is 5x, 2 into x, 2 in the bracket x plus 63 becomes 2x plus 126, 5x minus 2x is 126, or x is equal to 42. So we got the value of x is equal to, the one integer I have got as 42, but naturally the other integer will be 42 plus 63, that is 105, and we can verify it. 42 divided by 105 is 2 by 5, and that is the ratio of the two integers, and the answer is correct. The next example, Ruby has coins with her. There are some 5 rupees coins and some 2 rupees coins, but the sum of those coins is 88. So we do not know the number of coins of each. So let us assume that Ruby has 5 rupees coins which are x in number, and Ruby has 2 rupees coins which are 3 times that number, that is 3x. So the total amount she has is rupees 88. So therefore the number of coins of each type will be 5x plus 2 into 3x, because 5x plus 2 into 3x is equal to 88. So 5x plus 2 into 3x is equal to 8. Now question is why I have multiplied by 5 and 2 here, because there are x rupees 5 rupees coin, therefore the total amount of 5 rupees will be 5x, and there are 3x coins of 2 rupees, therefore the total amount will be 2 into 3x. Therefore we have got the total amount of 2 rupees coins, the total amount of 5 rupees coins, and when I add both I get 88 rupees. That is why I have multiplied by 2 and 5 here. So 5x plus 6x is equal to 88, 11x is equal to 88, x is equal to 8. That means the 5 rupees coins are 8 because x is 8, and 2 rupees coins will be 3x, that is 24, and we can verify it. 8 into 5 is 40, 24 into 2 is 48, and when we add we get 88 rupees, and therefore the answer of 8 coins of 5 rupees and 24 coins of 2 rupees is 100% correct. Now coming to the next very important example here, it is again a statement example. The length of fence is given as 300 feet. The farmer cuts this fence into 2 pieces. The longer piece is 4 times the shorter piece. That means we do not know both the lengths here now. Shorter piece is also not known and longer piece is also not known, but we have been told that longer piece is 4 times the shorter piece. So now let us assume that shorter piece is x feet, then the longer piece will be definitely 4 times x feet. Now we have to find the length of each piece here. So let us add these 2 pieces. When I add both the pieces, that is the shorter piece of x feet and the longer piece of 4x feet, we get x plus 4x is equal to the total length, that is 300 feet, and we simplify, we get x is equal to 60. Therefore the shorter piece is definitely 60 feet and the longer piece will be 4 times 60 feet, that is 240 feet. Now remember that. Now here we are given a rectangle and the breadth is b and the length is given as 3 meters more than the breadth, 3 centimeters more than the breadth. That means 3 more than the breadth. That is not only breadth, 2 times the breadth. That means L is equal to 2b plus 3 here. So please understand again, breadth is b but length is 3 more than twice the breadth, therefore it is 2b plus 3. But the perimeter is given and we have been asked to find out the dimensions of the rectangle. That means we have to find the breadth and the length here. So length is 2b plus 3, the breadth is b. Now we have been given perimeter here. Now we have to find the dimensions. Now let us see how we can do it. Now we know that the perimeter of the rectangle is 12 plus 2b, 12 plus 2b. Now L is 2b plus 3 and b is as it is. So it is 2 into L plus 2b becomes 2 in the bracket 2b plus 3 plus 2b. When I simplify it, I get b as 18 by 6 and b is 3 centimeter. And if I know b as 3 centimeter, length will definitely be 2 into 3 plus 3 and that is 6 plus 3, that is 9 centimeter. So that is how this example is is solved. So this is how we solve the examples given to us. The statement examples are to be understood, read, understood, assuming a particular one of the variables there, and then simplifying it, knowing the different formulas, because we have to know what is perimeter, what is area of a rectangle, and so on, and applying those basics we can solve these examples. So that is what is how polynomials can be used, or can be used in solving statement examples. Okay, so learn them, note down them in a book, and okay, as a reference for you. Okay, thank you.